Imagine waking up a few years from now. Before your feet even hit the floor, the blinds are letting in the morning light. Your calendar is sorted, and your coffee is already brewing. You didn't touch a button or say a word. The house just knew. To figure out how we get there by 2030, we look at something called scaling laws. Think of the current investment in computing power like a small snowball rolling down a snowy hill. As it rolls, it picks up more snow, getting larger and faster. By measuring its current speed and size, we can calculate exactly how massive it will be when it reaches the bottom. When we apply that math to the breakthroughs happening right now, a clear picture emerges. The individual pieces of a global upgrade are coming together. Just like the internet connected computers, the next few years will connect our physical world into a single network, a kind of operating system for the planet. This invisible layer of technology will manage our physical environment, coordinating everything from individual homes to entire city power grids. Every operating system needs a brain. For EarthOS, that brain is artificial intelligence. But the AI of 2030 is shifting away from simple chat windows and toward autonomous agents. Think of current AI like a helpful intern. You ask it a question, and it hands you an answer. An AI agent acts more like a manager. You give it a high-level goal, like planning a business trip, and it independently books your flight, blocks out your calendar, and emails clients in the background. But a brain needs a nervous system to send signals to the body. That is where 6G connectivity comes in. 6G acts as a massive superhighway that allows data to travel between devices almost instantly. This ITU chart compares 6G and 5G targets. Blue boxes show massive jumps in data capacity and speed. Crucially, under sensing capabilities, 6G signals bounce off objects to track position. It acts as a spatial radar, monitoring city traffic in real time without cameras. AI provides the intelligence to know what needs to happen, and 6G provides the instantaneous physical reflexes required to manage a city. Below those active thoughts, our OS has a subconscious running complex background tasks. This is quantum computing, a technology that handles calculations in chemistry and medicine that are too large for any standard computer. A regular computer solves a problem like a person walking through a maze. It tests one path, hits a dead end, turns around, and tries the next. A quantum computer acts like water flooding the entire maze all at once, finding the exit instantly. We are seeing physical proof of this. Google's Willow chip recently performed a calculation thousands of times faster than the world's most powerful supercomputer. With the brain and nervous system in place, the OS needs hands. Robotics will give AI a physical body to interact with our environment. We can see early hardware taking shape now, like the Tesla Optimus humanoid robot. Autonomous drones and connected vehicles will use this network to share their precise movements. By coordinating in real time, they can adjust their speeds to prevent bottlenecks and move through intersections without unnecessary idling. Quantum computing handles the heavy math in the background, while robots and automated vehicles manage the physical labor out in the world. Finally, any healthy system needs an immune system to protect it. For Earth, that means biotechnology and climate innovations designed to preserve our natural resources. Cultivating meat and sterile bioreactors is one way to secure the food supply. This method produces the exact same food using 96% less fresh water and generating far fewer greenhouse gas emissions than traditional livestock farming. We also have to protect our digital resources. We are generating data so quickly that we are facing a global storage crisis. The solution being developed is synthetic DNA data storage. DNA is nature's original hard drive. It is incredibly dense and lasts for centuries. By writing digital files directly into synthetic DNA, we can cram an entire warehouse of data into a space smaller than a grain of sugar. Using DNA as a storage medium allows us to keep massive digital archives readable for centuries, without the energy costs of a traditional server farm. Now, let's step back and look at the timeline. By 2030, you'll work alongside AI agents, receive packages via drone, and use the first 6G networks. But other elements will take longer. Scaling up physical hardware is difficult. Developing fault-tolerant quantum computers and cities full of humanoid robots will take time as we work through manufacturing limits and government regulations. Even with those hurdles, these 5 pillars, AI, 6G, quantum computing, robotics, and biotech, are converging. Understanding how they connect puts you in position to see the next decade before it arrives. The future is something we actively build. If you're curious how the deepest parts of this new system will operate, check out our next video, where we break down the exact mechanics inside a quantum computer.